Imagine waking up in New York, paying for groceries in Singapore, or hailing a ride in Dubai, all in the exact same second. In physical space, moving millions of people through a city creates inevitable friction. You can see it on any crowded boulevard. But in the digital space, coordination happens instantly. Every day, global financial centers process millions of transactions in fractions of a second, completely invisibly. We tend to credit the massive server farms, satellites, and thousands of miles of fiber optic cables for keeping this chaos organized. But that hardware is essentially dead weight. Without a guiding intelligence, our networks would instantly collapse. That invisible coordination depends on the specific instructions we feed into those machines. These instructions are the silent engines of the digital age. We call them algorithms. And if you strip away the glowing screens and the complex coding languages, an algorithm is a clear, organized sequence of logical steps used to solve a specific problem. It acts as a filter, turning an overwhelming avalanche of raw variables into predictable, actionable decisions. To find the original source code for this concept, we have to leave the digital era and look back over a millennium. 12 centuries ago, long before the first computer server, scholars were already tackling the problem of how to process complex information. The architect of a new way of thinking was Muhammad ibn Musa Al-Khwarizmi. He demonstrated that complex mathematical problems didn't require guesswork. Instead, they could be solved through clear, repeatable procedures. This shift from individual intuition to a documented step-by-step system allowed logic to be shared, refined, and eventually coded into machines. Over the following centuries, Al-Khwarizmi's systematic methods were translated into Latin, spreading his framework across borders. During that translation, the Latinization of his own name evolved from Al-Khwarizmi into algorithmi, eventually becoming the word algorithm. Today, every time we use that word, we are invoking the name of the 9th century mathematician who formalized the concept. When you take that ancient logic and run it through machines capable of executing billions of steps per second, the scale of problem-solving expands. This logic drove the space age, enabling NASA to calculate spacecraft trajectories and explore distant planets with mathematical precision. It also moves into healthcare, where algorithms analyze massive medical datasets to identify disease patterns and assist doctors with diagnoses. Today, artificial intelligence represents the most advanced evolution of algorithmic thinking. Modern AI systems apply Al-Khwarizmi's step-by-step reasoning to enormous datasets, allowing the sequence to refine itself as it processes more information. Despite the complexity of the data, an AI is still a machine following a sequential path to reach a solution. We build our innovation hubs out of steel, glass, and silicon, but those materials rely entirely on an invisible, logical foundation. Every digital action, from an online search to a global trade, functions because of this sequence of instructions. These rigid procedures replaced the human guesswork and physical paperwork of the past, allowing global systems to move at the speed of the data they process. The modern world is built with supercomputers and satellites, but it is ultimately united by a 1,200-year-old idea about how to solve a problem.